Okay, last lecture we have proved the limit of algebraic function, polynomial function and rational function, polynomial upon polynomial. And if there are two different looking functions, if you do domain correction, then for the trimmed domain, both different looking functions can be same functions and therefore their limits will be same. That is what exercise which we have done last lecture. So the next level of the functions, the commonly used functions, we should check the limit values for those functions. So theorem, basic trigonometric functions are continuous in their domain. Prove that limit sin x as x tends to c is sin c. I give you 5 minutes. Now, establishing these limits is using first principle. That means we are trying to use the definition of limit to find out these limits. Yes, last lecture we have done it for polynomial functions, rational functions, and today we are trying to do it for trigonometric functions. So, in trigonometric functions, what is limit sin x as x tends to c, we are supposed to prove sin c. So, we will go ahead exactly the way we were doing proof. Hope you are also trying to do that way only. Let epsilon greater than 0 be given. Okay. So what we are supposed to prove is f of sin x minus sin c is less than epsilon. To prove that. Okay, so now this problem becomes a trigonometric problem, and therefore you may use your trigonometry skills to deal with it. So sin x minus sin c can be written as 2 cos x plus c by 2 sin x minus c by 2 should be less than epsilon. बराबर है. Therefore mod 2, okay, then mod cos x plus c by 2, it is a multiplier function of x, multiplier function of x, and then you have sin x minus c by 2. Is that correct? And now what delta, what is our delta? Is mod x minus c should be less than delta. That is what is the algebraic quantity that we are looking for. And this delta should be expressed as function of epsilon. That is what relation we are trying to search. What if the epsilon is given, what value of delta we should take? That is what we are searching. And therefore, this is 2, so 2 is fine. This fellow is a multiplier function of x and cos, which is good. Therefore, the maximum value of this function you can consider as +1. It is always going to be less than or equal to +1, and hence you end up getting sine x minus c by 2 absolute value. And now you want some relationship of sine x minus c by 2 with maybe x minus c by 2, because you need to get rid of this sign. And therefore, another exercise is to figure out, are they well behaved? Are these sine x minus c by 2 and absolute value of x minus c by 2, are they well behaved? So if they are well behaved, we can have inequality in between and we can replace this sine x minus c by 2 is less than x minus c by 2, and we arrive at delta in terms of epsilon. That is our job. So what we need to prove now is, we are dealing with sine function, mod claim to prove that mod sine theta is less than mod theta, and you are interested between minus pi by 2 to prove that for every theta belonging to minus pi by 2 pi by 2, sine mod of sine theta is less than mod theta. If this identity is true, if true, then what we can do here is, we can directly write, let us finish this proof assuming that it is true. So this inequality is strict inequality here, and therefore this strict inequality multiplied by 2 makes it mod x minus c, I mean is less than x minus c, which is less than delta, correct? So delta is equal to epsilon. That is what we get. Delta is equal to epsilon. So to epsilon. So take delta is equal to epsilon and prove limit x tends to c sin x is equal to sin c. We will be able to do it without any problem. That 2 gets cancelled, x minus c and sin x minus c, we can replace it by x minus c, which is our less than delta, which is epsilon. So our proof will go through, and we will be able to prove the limit, and hence we will be able to prove the continuity. Okay, so what is pending is this. How do we go about it? Maybe I give you a couple of minutes to prove this. For every theta between minus pi by 2 to pi by 2, absolute value of sin theta is less than absolute value of theta. What we need to do is consider the geometry of definition of sin theta. So if we consider, and maybe first you consider theta between 0 to pi by 2, so you are comfortable. In the first quadrant, normally we are very comfortable because everything is positive. Suppose this angle is theta. Suppose this point P is P. Unit circle. You draw perpendicular. PM. Let this point be A. So the arc length that you have is r theta, but r is 1 unit circle. So this PA, arc PA, is equal to theta, and distance PM is equal to sine theta. Right? So if theta belongs to 0 to pi by 2, sine theta is less than theta. Of course, geometrically we are doing it. The moment you have theta not equal to 0, if theta is equal to 0, then we will have equality because everything will be 0. But if theta is not equal to 0, it is arc length versus perpendicular distance. Arc length is always going to be greater than perpendicular distance. Practically we are assuming it to be true using diagram, not proving.
तर आपण असं म्हणू शकतो का की perpendicular distance will always be the shortest distance?
Perpendicular distance will be always less than?
Sir, always be shortest.
Shortest. Yes, you can do that.
Sir, आपण पायथागोरसची करू शकतो.
I mean, okay, we don't get into those details. We know that PM is going to be smaller than PA, and therefore sine theta, and and therefore this implies mod sine theta is less than mod theta, and if theta belongs to minus pi by 2 to 0, then minus theta will belong to 0 to pi by 2, and therefore sine of minus theta we are supposed to prove less than minus theta, taking absolute value sine, I mean minus of sine theta is less than minus theta, taking absolute value sine. बरोबर चालले ना रे? Is this correct?
हो सर.
Yes. So it is true for all values of theta between minus pi by 2 to pi by 2. This inequality is true, and therefore we get the limit sine x is equal to sine c. Because this was pending, we have used it here and we got it. Understood? Okay. Therefore, we are supposed to prove cos and tan. So I give it to you at once. You write down the complete correct proof of limit cos x as x tends to c is equal to cos c, and 3 limit tan x as x tends to c is equal to tan c. I mean, you need to take due corrections for domain, etc., but that is assumed to be available. So, using first principle, you have to prove this 2 and 3. I give you 4 minutes. Okay, when it comes to cos x minus cos c, again it is mod minus 2 sine x plus c by 2 sine x minus c by 2. Okay, absolute value. And therefore, proof goes exactly same way, because you take maximum value of sine x plus c by 2 as 1, absolute value of -2 is 2, and hence you select delta is equal to epsilon, you get cos x is equal to cos c, and therefore this proof will go through exactly same way, this way. And how will you do tan? It is a ratio theorem. You need not have to do the epsilon delta calculations again because we have ratio theorem with us. Sin x upon cos x. Sin x is sin c, cos x is cos c, therefore tan x is tan c, and hence we declare that using reciprocal theorem, what you can say is for limit cosec x as x tends to c is equal to cosec c. Limit, complete this, write this in your notebook also. Sec x is equal to sec c. And
So,
c, yes,
so can we say if limit of x as x tends to c is sine c, then limit of sine of pi by 2 minus x as x tends to c is sine of pi by 2 minus c.
चलेगा, yes, चलेगा, no problem. Okay, so trigonometric functions, that the theorem that we had written, all trigonometric functions are continuous in their domain. Trigonometric functions are continuous in their domain. This is what we had written and proved. Okay, next. Let A be subset of R. Let f comma g comma h be defined from A to R. Let C belong to R be cluster point. Let L belong to R. If 1 for every x belonging to A, f of x is less than g of x is less than h of x, to limit हॅलो हा 1-2 मिनिटात करतो मी फोन लेक्चर मध्ये करतो ओके ओके limit f of x as x tends to c is equal to L 3 limit h of x as x tends to c is equal to L, then for limit x tends to c, the middle function g of x is also going to be L. Okay, now this is called sandwich theorem. or it is also called squeeze theorem. Basically, if you have three functions, let me use different colors. One function goes like this, another function goes like something like this, and third function goes like this. At x is equal to c. This is c. Okay, so if you know that limit as x tends to c, this first function is f of x, this is f of x, this is g of x, and this is h of x. As x tends to c, if h of x and f of x tend to the same value, then they are going to take g of x also along with them. G of x just cannot disappear like this, just go somewhere and come back. It cannot happen because of condition number one, that g of x is always between the two. So it cannot just go out. It has to be well behaved. That is the geometric representation of squeeze theorem. However, we understand that it is going to happen. Intuitively, it is going to be correct, but we need to spend time in writing the epsilon delta correct proof of this. I give you 7 minutes. केले का तुम्ही फिजिक्स मध्ये प्रूफ लिहिले का? Now, any time epsilon delta proof will begin with epsilon greater than 0 begin proof. Let epsilon greater than 0 be given. So statement number 2 implies for every epsilon there exists delta 1 greater than 0, such that for every x belonging to belonging to deleted delta 1 neighborhood of C intersection A, we have absolute value of f of x minus L is less than epsilon. So let us write it this time like this: L minus epsilon is less than f of x is less than L plus epsilon. Is that fine? That is the meaning of absolute value of f of x minus L is less than epsilon. 3 implies there exists delta 2 greater than 0 such that for every x belonging to deleted delta 2 neighborhood of C intersection A, we have again L minus epsilon is less than. Third statement is about h of x less than L plus epsilon. That correct hai? Good. Choose delta is equal to minimum of delta 1 comma delta 2. What will happen? Note delta greater than 0, and for every x belonging to deleted delta neighborhood of C intersection A, 2 and 3, not 2 and 3, 4, 5 and 6. 5 and 6 are true. 1 implies. We have not used condition number 1 yet. 1 implies f of x is less than g of x is less than h of x, correct? So if we consider left hand limit of f of x, that means L minus E is less than f of x is less than g of x is less than h of x is less than L plus epsilon, implies L minus epsilon is less than g of x is less than L plus epsilon. By definition, limit x tends to c, g of x is equal to L. Straightforward. Now look at the elegance of this proof. Systematic. Every step is important and there is not a single word which is extra. Everything is spot on. From this point onward, choose delta, minimum of delta 1 comma delta 2. From this point onwards, what we are trying to do is we are trying to satisfy the definition. So, definition of limit, very important. It is if and only if. Because this definition is given, we got statement number 5 and 6. So we use the definition in one direction, 5 and 6. And after choose delta, we are using the definition of limit in the other direction. We are satisfying all the, so let us say limit f of x as x tends to c. We define limit as if and only if, then RHS. Whatever we have written in RHS, for every epsilon greater than 0, there exists delta greater than 0 such that for every x belonging to deleted delta neighborhood of C intersection A, we have absolute value of f of x minus L less than epsilon. That is what is RHS. So 2 implies means this is given, we are trying to figure out this implication for step number 5 and 6. And from this point onward, the moment we get the correct data for us, we are trying to collect all the information about RHS from here to here and saying that now okay, everything is collected and it is exactly as per the definition of limit, and therefore you use the definition of limit in this direction, saying that limit g of x is as x tends to c is equal to. So that is what is very important in these epsilon delta proofs. It is if and only ifness of the definition of limit which is making you write these proofs, and they are going to be absolutely correct. Again, have you understood? Now this is a very, very powerful theorem. Because why is it a powerful theorem? Because we are not unnecessarily spending our energy on the middle function which is g of x. Because you may know, you may not know what happens at C as far as g of x is concerned. We are not spending energy, it is unknown. I mean, maybe that function is so bad that you will not be able to find out. But then, if it is surrounded by two good functions and they are well behaved, they are easy to analyze, and their limits exist, and their inequality is consistent. Of course, if this inequality is not consistent, it is not going to work. But then, in the delta neighborhood of C, if that inequality is consistent, then using squeeze theorem. So, sandwich theorem is helping us dealing with complicated functions which are sandwiched between two easy functions. And that is what is the estimate. Have we really tackled g of x? No, we have not tackled g of x. Because f of x and h of x were easy functions and were surrounded, we could deal with them, and therefore we said, okay, g of x also is going to be well behaved, and at c it will behave like this. So this is very important breakthrough in this entire notation that we are trying to create, and this will open up many indeterminate limits for us. And therefore the first application is, let us write down the first application of this theorem. If theta is between 0 to pi by 2, here. Then prove that. Oh, it is a theorem. So then limit sine theta upon theta as theta tends to 0 is equal to 1. This is the first application of sandwich theorem, and in many more places while solving problems you will have to use this theorem, and therefore it is important. Now see, it is not just using this theorem. What are the prerequisites of this theorem? They are important. Unless and until all the prerequisites are satisfied. What are the prerequisites? That g of x must be a middle function. F of x and h of x are surrounded by g of x is surrounded by f of x and h of x. Limits of the surrounded functions exist and they are equal. So these two are important conditions. Then and then only we get the middle function equal to x. So you need to keep searching for the now see, now these surrounding functions, it is up to us which to choose for getting this. Now here the complicated function in our example is sine theta upon theta. If we directly substitute theta is equal to 0, we end up getting 0 upon 0, which is the first indeterminate form. And in calculus, in pre-calculus mathematics, we will say we will not deal with this. We don't know what this is, and it is not in our scope of supply. But now in post-calculus mathematics, this is the first theorem where we have the answer, and it is a very nice answer which is equal to 1. So it is now important that you prove this equal to 1. I give you 6 minutes. Resume recording. So hint for this problem is this diagram. Unit circle, ray OP, point A, join PA, draw tangent at A, it intersects ray OP at Q. Consider areas of triangle POA, sector POA, and triangle QOA. They have these strict inequalities because x is not theta is not equal to 0, nor it is equal to pi by 2. In between, always these inequalities are going to be strict. Using this, we should be able to get this limit, and of course, it is application of sandwich theorem. Therefore, you have to use sandwich theorem. Finish it now. Okay, so area of POK, if I want to write down, then it is half OA OP sine theta, which is going to be less than area of sector is half r square theta. R is 1, so maybe r square theta, and area of triangle QAO is half into A into QA, right? So this is 1, half goes from everywhere, 1 1, so this is sine theta is less than, this is 1 square, half goes, therefore this is less than theta. and QA upon OA is tan theta, right? So here theta is in radian. Theta is in radian. Otherwise, this area will be wrong. Theta is in radian. Now, therefore, can you divide everything by sine theta? As sine theta is greater than 0, 1 less than theta upon sine theta less than tan theta upon sine theta, which is cos theta. If we flip inequalities, we will get cos theta is less than sine theta upon theta is less than 1. Now taking limits, of all the three, we get limit cos theta as theta tends to 0 is going to be less than limit sine theta tends to 0 1 theta is going to be limit 1 theta tends to 0.
तर लिमिट्स इक्वल असणार.
हॅलो, हा बोला. हा, आम्ही मी पाठवू का पत्ता? MITच्या मागच्या बाजूला, बॅक गेटला, MIT कॉलेजच्या. हा हा, स्नेह पॅराडाईज पासून वरती यायचं, पुढे अजून थोडं वर डोंगराकडे. हो, नाही, त्याच्यामध्ये एक रस्ता आहे वरती येणारा, डोंगराकडे येणारा. हा, ते स्नेह पॅराडाईजच्या आधी झालं. स्नेह पॅराडाईज कडनं तुम्ही समोर आलात की एक मोठा टेनिस कोर्ट असलेला मोठा रस्ता लागतो. हा, त्या रस्त्यावरती डोंगरच्या साईडला आलात की लेफ्ट साईडला गेली. हो, शिल्पा सोसायटी, शिल्पा. हो, चालेल चालेल, ओके. हा, काय म्हणत होता? इथे इक्वालिटी टाकू का? लिमिट इक्वल असण्याची शक्यता आहे, बरोबर, करेक्ट. अँड देअरफॉर द लास्ट स्टेप इज 1 इज लेस दॅन ऑर इक्वल टू लिमिट साइन थीटा बाय थीटा टेंड्स टू 0 लेस दॅन ऑर इक्वल टू लिमिट 1. Therefore, this limit is 1. So we got this proof done. Now, this is important and it is being done very systematically with proper development of notation. Otherwise, sine theta upon theta was not answerable. It was indeterminate. Now we can answer sine theta upon theta is equal to 1. So now let me ask you a few questions based on this. Can you tell me this quantity? Limit 50%. Limit sine 2 theta upon theta. Theta tends to 0 is equal to. Yes, show me your answer. अथर्व करेक्ट, केतकी करेक्ट, मोहित करेक्ट, साहिल करेक्ट, आर्यन करेक्ट, सुधर्मा करेक्ट, श्लोक करेक्ट, ईशा करेक्ट, अथर्व कुठे वाचू 1 दिलेस का उत्तर? अथर्व वेळनाळे माहिती नव्हती तर मला कळत नाही. अनिश करेक्ट. नीटली सेपरेट उत्तर आणि दाखव. सक्षम करेक्ट. प्रणव करेक्ट. हर्षिता करेक्ट. अनन्या करेक्ट. तन्वी करेक्ट. नयन गोगारी करेक्ट. मल्हार करेक्ट. नयन करेक्ट. आत्मज किती 0. बरोबर. चला परोळेकर करेक्ट. सो द आन्सर इज 2. And how do you get this answer? System limit 2 theta, limit sine 2 theta upon 2 theta into 2. Theta tends to 0 is equal to limit sine 2 theta upon 2 theta. Theta tends to 0 into limit theta tends to 0 2. Now, who gives us this permission to split the limit in 2 parts? That is what is our product theorem. Product theorem. Limit of this is L1, limit of this is L2, then limit of product is L1 into L2. And if both of them are L1 and L2, if they are different than L1 and L2, not finite number, then this permission is not available. And therefore now replacing 2 theta by alpha, we get sine alpha upon alpha as alpha goes to 0 or alpha goes to 0, something like that. You can do the change of variable, but this is very simple. Therefore, answer for this is 1 and answer for this is 2. Therefore, overall answer is question 2. Limit as theta tends to 0, sine theta upon 5 theta. This is easy. Question 3. Limit theta tends to 0, sine theta upon theta square. Okay, I give you 4 minutes, 3 minutes for these 2 problems. Okay, so question number 2, answer is 1 upon 5 and steps are going to be exactly identical to this. There is no issue. However, this is bit dangerous. Now, you can split this sine theta into 1 upon theta square. That is one way of splitting these 2 functions. You can split them as sine theta upon theta into 1 upon theta. That is another way of splitting this function. And third is as it is, which is given. And now, if you split it like this, limit theta tends to 0, and here again limit theta tends to 0, then what will be the answer? In this case, let us try to find out. And if you split it like this and write limit theta tends to 0 and limit theta tends to 0, in this case, what will be the answer? Okay, so this limit is straightforward. As theta tends to 0, sine theta is going to be 0, and as theta tends to 0, 1 upon theta square, as theta tends to 0, is going to be plus infinity. We have not defined this yet, but we know the graph is going to be like this. Correct? And therefore, as you go near 0 from left hand side and right hand side, you will go to plus infinity. So this is going to be plus infinity. And it is actually back to square 1 because this was 0 upon 0, and therefore we were not able to find out the limit in this case. This is 0 into infinity is as good as 0 upon 0. Okay, so therefore this is also indeterminate form. Even if we split them in this fashion, it is still indeterminate form. So maybe we will be able to answer by splitting it in this way. This is equal to 1, first part. and second part is does not exist. So we practically we will not be able to perform this step of splitting limits because limit of this is not existing. Okay, so I'm not saying that does not exist into 1 is equal to does not exist. That is also not correct statement. Understand this. Okay, so that is not I am trying to say does not exist into 1 is does not exist means we cannot talk anything about limit and we really do not know what it is. Therefore, this way also splitting it gives us the answer does not exist, and this therefore even if it is 0 upon 0, this is 0 upon 0 form. Answer is does not exist. Okay, so question 4, limit as theta tends to 0 sine theta upon theta cube is equal. सांगा बघूया. Okay, so answer for 4, how would we like to split it now? Again, the straightforward way of splitting it is limit sine theta upon theta, theta tends to 0 into limit 1 upon theta square, theta tends to 0. Now, this definitely exists and is equal to 1. We need to figure out what do we mean by this, but as far as graph is concerned, it is plus infinity. And plus infinity into 1 is supposed to be plus infinity. I don't know, but yes, we can prove this. And therefore, this limit is plus infinity. Question number 5. Sine 7 theta upon sine 5 theta. Limit theta tends to 0 equals.
सर ह्याचं प्लस इन्फिनिटी आलं तर मग थर्ड क्वेश्चन मध्ये डज नॉट एक्झिस्ट
मल्टीप्लायर 0 होतं ना इथे, म्हणून 0 अपॉन 0 झालं ना मग शेवटी द्या. अरे
Sir, but in the second way, we got 1 into limit of 1 by theta. In the second,
Yeah, na?
yes, sir.
Yes. So, amongst the two ambiguities, we were trying to remove one. Therefore, we did it like this. So, at least this limit is 1. But then we failed to figure out what is the limit of this. And it was not existing. Therefore, we cannot predict the limit of this. Now, we are dependent on a very weak internet connection. I'll have to check. But before that, you solve this. Sine 7 theta upon sine 5. This is easy. You should show me the answer. I should.
Okay, sir.
Write sine 7 theta upon sine 5 theta like this. Of course, yes, we can write. Because this is pre-calculus algebra. I can divide and multiply by some number if it is not 0. I can always do this. And then I will have to check while giving limits to each individual. I have to only check that this limit exists and is finite. This limit exists and is finite. This limit exists and is finite. Because we have got the algebra of limits for L1 and L2. Those are the finite values of limit. L belongs to R. L is equal to infinity doesn't make sense. L1 and L2 belong to R, that means they are finite number. So if this is a finite number as far as limit is concerned, if this is a finite number as far as limit is concerned, and if this is the finite number, then of course I can limit of this product is product of the limits. I can use that product theorem and say that this is 1, this is 1, and this is 7 by 5. Therefore answer is 7 by Rajavardhan. Okay.
Yes, sir.
Next question. Question 6. Question 6 is limit theta tends to 0, 1 minus cos theta upon theta square. Find out. Okay, answer is so 1 minus cos square theta is 2 sine square theta by 2. Now you have, so you should adjust it by theta by 2 square, but then you are unnecessarily multiplying by 4, so you should multiply this by 4, something like that. Barabar? This is equal to 2 into 1 by 4 is half. So limit theta tends to 0 half into limit theta tends to 0 sine theta by 2 upon theta by 2 into limit theta tends to 0 sine theta by 2 upon theta by 2. So this is half into 1 is equal to half. Question 7. 1 minus cos A theta upon 1 minus cos B theta. Limit theta tends to 0 is equal to. Ada. Okay, so answer for this question again is going to be equal to A square upon B square. Last question in this series, question 8. Limit theta tends to 0, tan theta upon theta is equal to easy. Okay. So up to this point, okay, by the way, the answer for tan theta upon theta is 1, because you can always split tan theta as sine theta upon cos theta, and sine theta upon theta is 1 and 1 upon cos theta is 1, therefore the answer is 1. Now, so far up to this point, whatever evaluation of the limit that we have done is based on the theorems that we have proved and the definitions that we have created. Eventually, every limit that we have proved today can be taken backward to epsilon delta proof. But we will not keep writing epsilon delta proof because it is going to be long, and we are creating new theorems. Sandwich theorem will take care of many epsilon delta proofs that we are going to write, because we have written the proof of sandwich theorem using epsilon delta. And that is how we are constructing. Now, this answer which you have given plus infinity is not really justified at the moment, because we really do not know what do we mean by limit tending to plus infinity. We know what is the meaning of limit tending to L, where L is a finite value, finite real number. But when L becomes plus infinity, will the definition of limit change? When L becomes minus infinity, will the definition change, etc. So we will have to create 8 different definitions of limit, which will take some time. So I'm not going to start writing those limit definitions right now. I am going to free you 10 minutes before time today. Okay. So